Photography has always been a lifelong hobby for me. And we look at things that from the naked eye appear to be very simple, crystals. But when we look at these at molecular level, we bring out the inner beauty and also the complexity that we try to understand and approach, just like a photographer. Through unique angles, we can actually make a difference in developing an understanding of materials.
Engineers have an eye on not just curiosity about what you can see and observe, but how can you use it to make people's lives better?
We're always looking for complex problems where there's lack of theory or lack of understanding.
A major element here is this visualization, this ability to see what we couldn't see before.
What you find is when you start using tools to look at the surfaces of crystals at near molecular level, the beauty really pops out. You can design molecules that will come and bind to these crystals and influence these processes. For example, in kidney stones, in the last 30 years, there have been no new developments of therapeutics. And so this is where engineering can have a big impact, how we address these critical problems. Also, you have areas like malaria where we know how current drugs work, but from a fundamental standpoint, we don't know their mechanisms of action. These are challenging areas where we've made great strides in how to design new materials. In the area of biomedicine, we've been able to think of new ways of designing drugs that can target crystals. And in doing so, we're treating some of the world's deadliest maladies. On the other hand, with catalysis, we're really approaching complex, non-classical pathways of crystallization.
In the petrochemical industry, zeolite is a crystal. And so Jeff was able to focus on the fundamental study of crystal growth and then span out to malaria and kidney stone.
By understanding this, we're making a huge step forward in fundamental science.
I think every scientist wants to leave some kind of lasting legacy. And for me, particularly, I've really been inspired by fundamental aspects of research, looking at mechanisms of how crystals grow.